Lesson 3-4, all quantities are not created equal. Our learning objectives will be 1. To demonstrate the procedure for solving a linear inequality, and 2. Solve application problems that involve linear inequalities. I will need for you to pause this video and take the time to read the highlighted sections. So I'm going to start reading right here. A statement that one quantity is more or less than another is called an inequality. The inequality 2 is less than 5 is a true statement. The inequality x is greater than 3 is a statement that the variable quantity represented by x is more than 3. Just like with equations, the solution to an inequality is the set of all numbers that make the inequality a true statement when substituted for the variable. So there's going to be more than one answer to number 1 and 2. It says name a number that makes x is greater than 3 true. Well, I have an infinite number of choices. I could say 1,000,000. I could say 3.1. There are so many other choices. 2. Name a number that makes x is greater than 3 false. Well, I have an infinite number of choices here. I could even say 3. 3 is not greater than 3. 2.9 is not greater than 3. Negative 1,000,000 is not greater than 3. In many ways, solving inequalities is similar to solving equations. For example, the first step we identified in solving equations was to use the distributive property and combine like terms to simplify each side of the equation as much as possible. The same is true for inequalities. Surely most folks would prefer to work with a simpler inequality rather than a more complicated one. After doing that, we'll use tools similar to the ones we learned for the equations to rearrange inequalities with the goal of isolating the variable we're solving for. Now, in general, I like to move the variable to where it's on the left-hand side of the inequality. And I'm going to pause this video, or ask that you pause this video and review the tools that we had talked about in the earlier section. Do these tools work for solving inequalities too? Let's see. Remember, by work we mean that we can do these procedures to an inequality without changing whether it's true or false. We'll use less than to explore new rules, but the rules will also apply to greater than, less than or equal to, and greater than or equal to. In questions 1 through 4, fill in the comparison symbol that makes the inequality true after performing the operation. Now I'm going to do the first one, and then I would like for you to pause the video and try 2, 3, and 4 by yourself. So the instructions are for us to add 8 to both sides. Okay? So right now we know that 10 is less than 20, and we can agree with that. And if we add 8 to both sides, I get 18 on the left side. Here, let's change the color there. And I get 28 on that right side. Is the comparison symbol still the same? Yes, it is. So do the same with 2, 3, and 4. Okay, so take a moment to inspect 2, 3, and 4. Is it the same thing you got? I suspect 2 and 3 are just fine. For some of us, subtract negative 6 from both sides. Remember, that is 10 minus a negative 6. That's why that is 16. And 20 minus a negative 6. That is why that is 26. So on number 5, they are asking for us to fill in does or does not to complete our first tool for solving inequalities. Then follow the remaining instructions in the box. It says adding or subtracting the same number on both sides of an inequality. It looks like it does not change the direction of the comparison symbol. Seems like if it was less than before, it stayed as the less than. All right, so they're asking us to use the inequality tool number 1 to solve each inequality. Then graph the solution set on the number line. Finally, choose any number in the solution set and plug it back into the inequality to check that it makes the inequality true. Note, when graphing a set of numbers on a number line, include a filled-in circle at the endpoint that is included in the set and an empty circle if the point is not included. So I'll do the first one, and then you'll pause the video and try the second one, and we'll check that. All right, so we have x minus 5. How do you undo minus 5? Well, we're going to add 5 to both sides. So now I have x is greater than 14. Okay, so I'm going to put 14 right here in the middle of the number line. I'll put 15 here, 13 there. Now it's greater than, so it does not include 14. So I'm going to do an open circle. And then it's greater than, so I'm going to shade to the right. Now I'm going to pick any number that's to the right of 14. I'll try 15. Is 15 greater than 14? Yes, it checks. All right, your turn. Okay, I subtracted 11 from both sides and got t is less than or equal to negative 6. Since it's an or equal to, I'm going to fill in that circle. And less than means we shade anything to the left. I chose negative 7 for my check, and it works out. Negative 7 is less than or equal to negative 6. Number 6, write a verbal description of what the solution sets to the two inequalities in the colored box. Back on page 330 at the bottom really tells us. The first has been done as an example. So this is what was on the box on the previous page. And they're saying any value of x greater than 14 will cause x minus 5 to be greater than 9. So again, we'll pause this video and you try the verbal description of what's going on to this scenario right here. Okay, first of all, I notice a scriber's error that should be t is less than or equal to negative 6 up here. So any value of t less than or equal to 6 will cause t plus 11 to be less than or equal to negative 6.